So in the last video we talked about this code, or better we talked about the background of that code, and it's always fascinating, for me at least, that we have to do so much theory and then we get that short code and we can run that code for matrices A, which are 3 rows, 3 columns, but also for matrices which have 100 rows and 100 columns. That's really fascinating. Okay, this was our code following our theory, and now I want to talk about a better implementation. This implementation is not very efficient. If you think about that for a longer time, then you may have some ideas to get the code faster when running. And being eager to be very efficient, you can spend a lot of time to improve. So in this case, it's better not to store the matrices Q, but to store the vectors omega. And so I do here in that code. And that means that after getting the decomposition, we have to adapt the code a little here. I don't want to go too much into detail. And here we have the code for the decomposition. More or less this is the same, but then we adapt the code a little bit. We don't use identity matrices. We reduce the code only for the interesting part where something happens, and so we get faster. As I said, I don't want to go into the detail. If you like programming, if you like the householder transformation, then it's not so hard to understand, but I think some minutes or maybe 1 hour is necessary to really understand what's going on. Here is also a parenthesis which is important as far as I remember when I wrote that code. That was some days ago. And then we get much faster. When I ran that code on my computer for a matrix which is 250 rows and 250 columns, then it was faster by factor 19. So that's a big deal, factor 19. And here we see that factor 19. The old implementation took 1.5 seconds, and the new implementation took less than 1/10 of a second. I want to talk about this better implementation, not because now we will always try to improve our code. This would not be, didactically, this would not be a good idea, I think. In the further course of the script, there are many places where faster implementations were possible, but I will not do so. I did so here for Householder because here it's maybe the most fascinating place how we can improve, but also for demonstrating that I know that often better implementations were possible, but I will resist in the further course of the script, and I don't want to talk about better implementations, even if it's not that hard. And I think you will be distracted by these details, so we keep the code simple. Okay, but if you want to build professional code on the theory of that script, then you should think about better implementation, and maybe you can also Google better implementations of these algorithms. And so you will better like the code keeping things simple.